solutions for your most complex challenges, comprehensive results that help communities, economies, and natural places thrive. We're the team whose engineering and environmental expertise delivers these outcomes. Around the globe, our engineers, scientists, and technical specialists focus on solving our clients' problems as if they were our own. With BAR's resourcefulness and dedication, you'll find solutions in engineering and design, environmental investigation and remediation, permitting and compliance, sustainability and resiliency, and water management. All our work begins with listening, because your problem deserves a tailored solution from consultants who share your passion and integrity. Because your evolving needs require an agile partner who can dive in and assist at any point along the way. We're here at every step to deliver an exceptional experience, sustainable solutions, peace of mind. Together with BAR, you'll find the best answers to your biggest challenges.
Hello, and welcome to Building Your Water Reuse Strategy. I'm Bailey Hadna, Environmental Engineer at BAR Engineering, and I'll be your host for today's webinar. To give you an idea of what the next hour will look like, I'll start with a brief introduction to BAR, and then I'll have our speakers talk through how to build your water reuse strategy based on their expertise and experience. And then we'll have about 15 minutes at the end of the session for questions and answers. Before we begin today's presentation, we have some logistics to go through. So first, if you're having any trouble with Teams at all, send an email to Lisa Unger at lisaunger@bar.com. She's our admin assistant for today, and she can help you through whatever questions you have. Second, the chat function in Teams is disabled. And so instead, we'll use a link to a form in the chat that will submit questions or discussion topics on the fly, and we'll have our presenters go through them at the end of the session. And I encourage all of you to submit questions during my colleagues' presentations, and we'll accumulate these and address them in the final 15 minutes of today's session. Third, you should be viewing the presentation slides yourself. These will be sent out at the end of the session along with a recording of the webinar for your review and viewing. And then finally, we will share our emails at the end of the session as well. And if you have questions after today, please feel free to reach out to any one of us directly. A little bit about BAR. BAR has decades of experience working in water, dating back to our founding in 1966. Our work in water includes engineering and environmental services, which involve water storage, treatment, and distribution, as well as protection and restoration of wetlands, watersheds, lakes, and streams. At BAR, we're fascinated by how water flows and the many ways it flows through our lives. Depending on the setting, as we all know, water can be sustaining or life-threatening. It can be aesthetically beautiful or powerfully destructive. It can be dependable, or it can be wildly out of control. And bringing these variables into balance has been a cornerstone of BAR's business for decades. And many of our scientists and engineers have devoted their careers to unlocking better ways to direct, extract, contain, and preserve Earth's most essential natural resource. So whatever you may need in your organization and however you use water, BAR is ready to work with you and address those issues. As I stated, BAR has been working with water for a very long time. Our earliest projects involved hydraulic engineering and hydrology going back to the 1950s. And for the 60 plus years since then, we've continued to build our breadth and depth of experience in helping clients manage water resources efficiently and responsibly, including groundwater, stormwater, and wastewater management. Although we have experts across the board, today we'll be focusing on water reuse and water treatment for reuse in today's session. And so now I'll introduce our speakers and their specific topics for the rest of today's presentation. So first we have Emily Ahasik. Emily is an ESG strategic consultant, and her experience in investor relations and corporate strategy, along with her knowledge of environmental, social, and governance, or ESG, landscape, and strong leadership skills when it comes to projects, enables her to help clients advance sustainability priorities and navigate the evolving ESG landscape. She works with BAR's industry experts and technical experts to identify and deliver advice and solutions that help clients achieve sustainability goals across various environmental issues. Next, we have Sharon Dahl, who is a senior environmental scientist at BAR Engineering. Sharon has more than 30 years of experience nationwide in areas of environmental permitting, regulatory compliance, and project management. And Sharon offers BAR's clients extensive insights into and guidance on multimedia compliance audits, National Pollutant Discharge Elimination System, or NPDES permitting, remediation programs, and stormwater and hazardous waste permitting and regulations. Next, we have Aklima Hossain. Aklima is a senior chemical engineer and has nearly 25 years of experience in project development, conceptual and detailed design, procurement, installation, startup, and construction support for water treatment projects. She has served in various project roles with her time at BAR Engineering, and including project manager, lead process engineer, and senior technical consultant. And Aklima's technical areas of expertise are water and wastewater treatment. At the end of today's presentation, I'll return to moderate any questions you submit throughout the chat and make sure that we can get our questions answered by our presenters. And now I'll hand it over to Emily for our first section of the presentation.
Thank you, Bailey. Despite some of the projections out there, it can still be easy to take the availability of water for granted, particularly in much of the United States. But the need to conserve and reuse is becoming increasingly important as our global population continues to grow and certain geographic areas face increasing levels of water stress, including western parts of the US and other regions of the world. So what is water reuse? At a high level, it involves taking water from one or more sources, treating it to meet certain quality levels, and reusing it for beneficial purposes. Effectively treating and reusing water can help address scarcity and quality issues, as well as provide other benefits, such as increased resiliency and water security. Here's a snapshot of some of the sources and ways in which we use and reuse water throughout our shared ecosystem. We commonly think of lakes, rivers, and streams as water sources. but stormwater can also be a very important part of an industrial water cycle. Facilities can potentially reuse it to reduce the amount of water being withdrawn from other sources. As water scarcity continues to be a key issue for our planet and for society, stakeholder pressures and regulations are likely to continue to evolve and drive companies to act. Treatment and reuse are tools that can be considered in determining how to best achieve your goals in a way that's economically viable. So how do you get started? First, it may seem really obvious, but it is so important to clarify internally what is driving you to address water reuse for your organization. It might be a corporate or site-level sustainability goal, rising stakeholder expectations, or emerging regulations. And different parts of your organization may have different ideas about what water reuse is and what defines success. So it is good to make sure everyone is on the same page as early as possible. Second, even if your primary driver is a voluntary goal, it's important to consider both existing and emerging regulations. These include rules related to human health and safety, water sources, consumption, and discharge. Sharon will talk about these in more detail in a few minutes. Third, establishing a baseline is foundational to setting realistic goals and demonstrating meaningful progress to your stakeholders. This involves quantifying what is coming into and going out of your facility and is called a water balance. It also includes evaluation of the various quality needs of water users throughout your facility, as well as any potential changes that could impact your future water needs, such as plans for production expansion. Last but not least, once you understand your current and anticipated future use, as well as regulatory considerations, you can then begin to think through what is possible in terms of treatment and reuse, including what types of technologies may be able to help you. Let's talk more about step one, confirming your drivers. Here are some common drivers we hear from clients. You can see these range from cost savings and regulatory developments to things like customer expectations, differentiation, and competitive advantage. Companies often have more than one driver, but not all drivers typically have the same level of importance, and those priorities can change over time. Additionally, different parts of a facility may have different needs and expectations, going back to being aligned internally on what you are collectively trying to accomplish. These are a few examples of projects we've done with clients to address some of the drivers I just talked about. The solutions shown here range from water conservation to storage, treatment, and reuse. As Bailey mentioned, BAR has been helping clients solve tough challenges related to the management of water and other natural resources for over 60 years. Our employees are truly passionate about this work and enjoy partnering with clients to understand their needs and help them achieve their goals. This particular project was done with one of our global manufacturing clients. They had established a sustainability goal to reduce water use by 25% across their overall geographic footprint. They also set a long-term goal to achieve zero liquid discharge at one of their facilities in the Midwest. We were engaged to evaluate their current state, recommend improvements, and ultimately design a treatment solution for their Midwest facility. Our first step was that foundational one, to develop a water balance. This involved quantifying the flows coming into and going out of the facility, as well as understanding quality needs throughout the site. We then assessed the capacity of the site's existing equipment, including storage tanks, pumps, and pipes. Next, we developed a model to compare the quality and volume needs of the various water users throughout the facility to the capacity of the existing equipment. And based on this analysis, we identified two key opportunities for reduction and reuse. The first involved reducing potable water usage by switching buildings over to non-potable water through piping and pump upgrades. The second opportunity involved designing a system to treat water so it could be reused throughout the facility. So what happened as a result of this work? Within 2 years of the installation of a reuse pipeline, the client saw a 10% reduction in overall water use from their established baseline, which was in line with their initial target. As I mentioned earlier, regardless of what is driving you to pursue water reuse, be it sustainability goals, operational efficiency, production growth, or other factors, regulations definitely come into play. Sharon will now talk through some of the key considerations at both a state and federal level.
Thank you, Emily. Hello, my name is Sharon Dahl, and I'm going to provide you with some basic information regarding regulatory considerations of water reuse. As a reminder, this webinar is not intended to provide all-inclusive and all-necessary information for water reuse projects. If after this presentation you have questions, please reach out to your bar representative for further information. In the next few slides, we'll be walking through water reuse examples, as well as discussing regulatory considerations. In this first example, we are taking water that is subject to appropriation limits and use restrictions, using it in our process, and then disposing of the water by means of discharge, land application, injection, evaporation, or other means. There is no type of water reuse being employed in this example. Water goes in and the water goes out. In this next example, we see that we are reusing some water internally. By recycling water, we could decrease the amount of intake water that we need on the front end, as well as decrease the quantity that we need to dispose of. The quality of the water disposed of may also be affected. In some cases, the discharge of water may be eliminated completely. For the third case, the water that the facility is using is being reused outside of the process. While you still have water appropriation limits and use restrictions on the front end, you may see a net decrease in water disposal, potential changes in the water quality being discharged, and in some cases, you may eliminate the discharge altogether. In the last example, we take a look at both water recycling as well as reusing water offsite. By employing both of these techniques, we reduce the amount of water that is needed, along with modifying the quality and quantity of discharge water. This will decrease water disposal and once again may eliminate the need for discharge altogether. In considering if water reuse is right for you, there are several categories of regulatory requirements to consider. These regulatory requirements vary by location and may come from a mixture of federal, state, and local regulations. First, it is important to understand which sources of water are allowable to be reused in your jurisdiction. One question to ask yourself is, are there regulatory restrictions on the sources and amount of water that may be reused? Additionally, it is important to understand how the water is allowed to be reused. These requirements may come from a mixture of federal, state, and local regulatory agencies focused on protection of public health, agriculture, and the environment. Some questions to consider are there restrictions on what water may be reused at the facility? Are there water conservation requirements to be considered? Are there water quality requirements that apply to what the water is being reused for? In our opinion, offsite water reuse is the most complex regulatory component for water reuse. Any external or offsite reuse of water will require approvals. These may come from irrigation permits, Department of Health, agricultural regulations, local ordinances, or others. And finally, it's important to consider how water reuse could affect compliance with water disposal regulations. This could be disposal of the effluent via an NPDES permit, but not necessarily. Water could also be impounded, evaporated, land treated, injected, as well as other means of disposal. There are regulatory programs associated with each one of these disposal options. Also, Any disposal permits and regulations would need to be considered when discharge flows and loads change. So, if recycling or external reuse is considered or implemented, impacts to those programs will need to be addressed. Water reuse may help you to comply with or may pose challenges for compliance with regulatory requirements. For example, water reuse could help you comply with water discharge quantity limitations, and water reuse could also help you eliminate or reduce discharges of wastewater or stormwater that require regulation, thus eliminating or reducing associated regulatory requirements. However, water reuse could also pose compliance challenges if reused water, more concentrated pollutants is discharged to the environment or publicly owned treatment works. Overall, it is important to evaluate both positive and negative impacts of water reuse on regulatory compliance for your facility. Keep in mind that this information is a high-level overview of the types of regulations that may apply, and that you should verify the requirements of your specific federal, state, and local regulatory agencies as they pertain to your water reuse projects. Shifting to federal requirements, EPA is becoming more and more sensitive to the needs of the communities and industries to implement water reuse projects. In order to assist businesses in understanding the regulatory requirements, EPA has a website that helps facilities understand their state requirements as it pertains to their water reuse. This is an excellent website to get regulations both at a federal level and at a state level. EPA is working with permitting authorities to better understand the broad range of permitting approaches, to explain how the permits can accommodate and or incentivize water reuse, and to encourage both permitting authorities and permittees to work cooperatively when permitting water reuse projects. The EPA website provides a high-level summary of each state's water reuse regulations, along with guidance depending on how you want to reuse the water. The lists to the left here are a few areas where water reuse regulations exist for certain uses. In 2020, the EPA released the National Water Reuse Action Plan, also known as the RAP. This national approach is meant to encourage water reuse while protecting public health and the environment. This information can also be accessed through EPA's website. There are many more tools such as the Water Reuse Association, the National On-Site Wastewater Recycling Association, the Water Reuse Foundation, and the American Water Works Association, which contain additional information on water reuse. Understand that regulations do exist for water reuse in most states and should be considered prior to initiating any water reuse project. This table here summarizes some other regulatory requirements that may need to be considered for water reuse projects. And finally, you need to be aware of the many state agencies that could be involved in the way that you are planning to reuse your water. In the state of Minnesota, for example, the Department of Natural Resources assists in water supply planning and conservation assistance. The Department of Agriculture provides technical support to crop producers, food producers, and food marketers in safety of water supplies. The Department of Labor and Industry reviews variance applications for non-standard practices such as gray water and stormwater by the Plumbing Board. The Department of Health provides oversight on source water assessments and evaluation of common rainwater and stormwater reuse installations. The Minnesota Pollution Control Agency provides oversight for the municipal wastewater reuse, and the Minnesota Board of Water and Soil Resources ensures that states' soil and water conservation policy is being adhered to, along with the oversight for the Wetland Conservation Act. So as you can see, there may be several agencies that are required to be involved at a state level for water reuse projects. And as for upcoming regulatory changes, several states are in the process of revising their water reuse rules on potable water reuse, as well as implementing water quality standards on potable water reuse. We are currently seeing this more in the states to the west, such as Arizona, California, Colorado, and Washington, but anticipate additional potable water reuse initiatives soon in other states as well. And again, it is always recommended to verify the regulations for use in your particular state. Now I will turn it over to Aklima for discussion on water treatment projects.
Thank you, Sharon. My name is Aklima. I'm a chemical engineer at BAR, and I work mostly in the engineering and design of water treatment system. So like Emily discussed, you have a desired goal and then have looked at possible regulatory impacts. Next is investigating opportunities for water recovery. That is basically streams, their quality, quantity, and then treatment options to get you there to your objective. And then it may require that you need to go back to the front of the process, realign your goal, look at the regulatory requirements. So it might be a circulatory process. So here's a scenario. Your corporation is looking at reducing freshwater intake by 25%. It could be a voluntary good water stewardship goal, or let's say you're in Arizona and the recent droughts have you nervous. Would there be future regulations that might restrict freshwater supply to your facility? So where do you start? In today's presentation, I'm just going to give some basic general guidelines and share some project stories, and hoping that the takeaway would be ideas that will help you with planning. So where do we start? We look at a facility's water mass balance. That is basically all the waters that are coming in, all the waters that are going out, and the processes within. For example, stormwater runoff. It might be going to a pond, but now you could look at potentially capturing that, do some treatment, and using it within the facility. So when you start with the exercise of knowing all your water ins and outs and what's happening within the facility, it could be a simple water treatment, water mass balance, depending on your specific facility and the complexity of operation within. Typically, when a facility is fairly new, chances are water mass balance are truly representative of the flows, all the flow paths, flow rates, and quality. If not, it's been BAR's experience that updating a old facility water mass balance could take from few months to even up to 1 year. The whole point here is plan early so you can correctly identify what are potential streams that could be targeted for treatment and reuse. As you are doing the water mass balance updates, ask yourself if it is reflecting the current conditions. And that might mean walking down the facility with drawings. Find out if there are data gaps. Maybe there are some streams that you don't have flow rates and quality. So install flow meters, sample those streams. And when you're collecting and analyzing water samples, make sure that it is truly representative of the min, max, average values, because that impacts the water treatment equipment and how it's sized. Also, future potential impacts to flows. Maybe there is plans for expansion of your facility that the team evaluating the water options for water recycle is not aware of. So involve all the stakeholders early in the planning phase and in between, so you are totally aware of all the water flows, current, future, and how everything is related to each other. Updating the water mass balance can also be an auditing experience. Maybe you identify low-cost water solution, freshwater use reduction solutions, like, for example, fixing leaks, using high-efficiency toilets, capturing rainwater from rooftops. Or maybe you could end up identifying procedural changes that could save water. For example, vacuum solid waste spills instead of washdowns. Or if you don't have a stormwater pond in your facility, maybe install one where all the rainwater could be collected and reused. And as you are doing this water mass balance update and investigating your facilities, solicit input from plant operators. They are very, very valuable. And from personal experience, I can tell you they know stuff and could even have ideas, good ideas. And then combine the water mass balance with maybe energy audits, just in case your your facility has a sustainability goal of energy reduction. Well, water reduction, all the treatment equipment, that's going to use energy. So it might conflict with your parallel sustainability goals. So keep that in mind. So from your water balance, mass balance update exercise, you have possibly identified a couple of streams to be considered for recycle, reuse, define their flow paths and know their quality. And then the next thing is to, like, where, if I treated the water, where could I use it? So knowing the quality limits for those potential uses, and then again, agreement from your stakeholders on what you're planning to do. So all this basically goes into, I would call it like a project charter. And that's basically step one here, where you've identified possible users, you know what those quality limits are, and based on the quality limits, the next step is preparing a matrix of possible treatment solutions to meet those quality limits. And then conducting feasibility studies. At this point, maybe engage your engineering department or hire an outside consultant, but conduct high-level feasibility studies just to see, which treatment option might be viable. And then at this point, it might just be number of dollar signs, right? To basically make a matrix of XYZ technologies and their corresponding capital cost. And don't forget operating costs too, because that has, if you look at, for example, a 30-year life cycle between one treatment option than another, say one treatment uses higher amount of chemicals, so the net present value of that might end up being more than like a low-cost solution. So you need to take a holistic approach. And then narrow down from your number of dollar signs and feasibility, technical pros and cons to the most promising. And at that point, I need to delve into it a little bit more, do a, more narrow cost estimate, say, for example, a class 4 minus 50 plus 30, and basically evaluate what the treatment technology might be. So in treatment considerations, again, make sure you understand if there might be some future water quality changes. I'll give you a project example. There was one project where they installed a treatment system, and after 2 years, the feed water or raw water quality changed drastically because the plant changed where their raw water was coming from, like the fresh water was coming from. And so the treatment system installed was undersized, could not handle the extra species that was in the different water source. And then plan sufficient time for doing maybe bench testing and if needed pilot tests, because there's a lot of new innovative technologies now. Your specific facility, where it's located. It's best to basically unique water quality. So it's best to do some pilot testing before you spend millions of dollars installing a full scale facility. So the point here is plan ahead. Some cost estimate considerations. This is like lessons learned. There was a project for which I did a feasibility study, did a cost estimate. That was pre-COVID days. And then after COVID, that cost increased so much that now when I do a cost estimate, I do not scale from past projects because it no longer works. And then there's all these global issues going on right now. Labor costs have gone up. So a word of caution, not to scale from past projects, but try to get like current prices on materials and labor as you do your cost estimates. So again, like I was saying, after you've done your evaluations and cost estimating, high level looked at some treatment technologies, you may need to go back to the drawing board to say, okay, my 25% freshwater reduction goal is not viable. So maybe I need to cut it down to 20%, or maybe you made discoveries where you can reduce it, down to 50%, and that would be really great. Here's my definition of reuse and recycle. Reuse is like collection of rainwater from building roofs, very little treatment. You're basically repurposing the water. And recycle involves some level of treatment before you can use it. So I know this scale is a little bit busy, but what I basically wanted to point out is that there's different levels of treatment based on what your water source is and your final user. So like, for example, if it is, say, stormwater, all you need to do is filtration, and the filtered water could be used for cooling tower makeup. And again, depending on what your raw water source is, your treatment objectives are, there are many, many technologies that could be looked at. It's all project specific. Or maybe you're a zero liquid discharge facility. So, you need to filter, you need to demineralize, and then you need to get the last concentrated wastewater stream, you need to evaporate and make solid crystals. Again, there's a lot of technologies out there that are new. And again, leave time for all this matrix evaluation, cost evaluation, and if needed, bench and pilot testing. So here's a case study. This is water from cooling tower blowdown. The chemistry, as you say, is very unique. Very high TDS. Silica, sulfate. So for this particular plant, option 3 would have been best, where you're recovering all the water, but zero liquid discharge involves your primary treatment, secondary treatment, tertiary treatment, and it's very expensive. Option 1 would be, some treatment, but then you have a large reject stream. And this particular site had on-site evaporation ponds that could only handle 50 GPM of water. So we basically settled on option 2. which is higher recovery of water, about 90%, that would get down to the evap pond water storage limitations. And how do we do that? So here we had to look at different RO technologies, like up to like 4th stage RO treatment. And that might get you to the 90% recovery, but the reject stream is, as you're concentrating the water as you go from one stage to the other, the membranes are exposed to high TDS water, right? So it's a balance of chemicals, like example, antiscalants and so on, or use of a different innovative new membranes in the marketplace, right? But will this work or not? Unless you do pilot test, you can't be sure that it's going to work consistently year in, year out, because as the RO membranes foul, maybe you don't get the same recoveries in year 3 as you would, 6 months when it started. And speaking of RO membranes, this particular project, there were so many different types of ROs, so many things to consider. Again, bottom line is there are some innovative technologies out there, new type of membranes, promises. But again, I'm a type of person, unless I do a pilot test and it proves out, I would be hesitant to spend millions of dollars. So again, the point here is, depending on your facility, plan early. You might need to do some pilot testing. So now I'll hand it over to Bailey to summarize all the takeaways from this presentation. Thank you.
Thank you, Aklima. So today we've talked about our key drivers and how to plan for regulations, which, as Sharon stated, will vary state to state. We've also discussed how to evaluate your facility and create your own water balance based on quality of data and quantity of data. We've also talked about how to select appropriate technologies to treat that water for recycle and reuse. A few key takeaways that we would suggest. One is plan early. This will ensure that you have ample time to understand your facility and build that water balance. It gives you enough time to involve key stakeholders and make sure everyone is aligned to your key goals, and to make sure everyone has the appropriate buy-in for your process. Be sure to keep in mind how any changes you make to your water balance or to your production and your process impact your facility and impact your future needs. And finally, don't forget this process is iterative, and it's okay to redefine those sustainability goals and drivers as you move through the process one by one. So for example, as you can see on the slide here, if you get to a point where you're doing your water balance and evaluating your quality and quantity of data, based on that new data, it's okay to then redefine some goals and redefine your scope and go back to the beginning of the process to confirm your drivers and goals. So how can BAR help? With respect to compliance, BAR's expertise in developing water balances and helping clients with complex permitting efforts, as Aklima and Sharon both mentioned. However, our work with clients extends well beyond safety and compliance, and we work to help our industrial and public clients prepare for the future. As Emily mentioned, companies, cities, and states continue to establish water reduction and reuse goals in response to evolving stakeholder expectations and ESG disclosure standards. Given that, we are seeing increased demand for services that help clients better understand their water use, identify ways to be more efficient and reuse as much as possible, and of course, in the most cost-efficient manner. We work with clients to assess their operation, model potential scenarios, and design solutions that mitigate current and future water issues and risks, and we're happy to continue doing that. In terms of climate adaptation and resiliency, water availability remains a significant focus given climate change and a growing population, and it will remain an issue for the foreseeable future. BAR works with clients to help them reduce their water consumption, increase their reuse, and be prepared for impacts of climate change, in pursuit of advancing their sustainability goals, meeting expectations, and reducing operational risks and achieving cost efficiencies. And so now with that, I'll open the floor to Q&A, and I'll go back to moderate the chat for the questions that we have submitted. And as a reminder, please submit any questions you have by using that link in the chat. Thank you, and let's get started. Okay, thank you everybody for submitting questions in the form in our chat. Our first question is for Emily Ahasik. Emily, how realistic, in your opinion, is it to achieve zero liquid discharge?
So zero liquid discharge, we talked about it in the example up front. It's quite ambitious. As Aklima mentioned, it's expensive. So there's a high hurdle to achieve there. And then it also can be really energy intensive too. And so back to the point of making sure you're looking holistically at overall environmental impacts and as you set your sustainability goals, doing that, because obviously there's a greenhouse gas consideration related to the energy use and cost as well. Certainly we've seen companies do it per the example I shared, but this is a concept that's been around for many decades. I think the technology is evolving and it's something to be paid attention to, but even with the example we shared, I mean, that is a company very focused on water, sustainability generally, but specifically water, and putting significant investment there. And the goal was limited to a specific facility, and there's a long-term horizon related to it. So looking for the stair steps and interim goals is a really good place to start. I would also add there are some facilities that just aren't set up to be conducive to that. Aklima, maybe you'd like to add a little bit of color there.
So I would just say every facility is unique. And so the approach needs to be customized for what that facility's objectives are, which could also include how much funding is available. So it's very, very unique depending on the type of industry.
Great. Thank you, Emily and Aklima. Just a reminder, there is that form in the chat if you want to submit questions as we go here, but we'll just kind of keep waiting for things to come in. The next question is for Sharon. So Sharon, what do you see as kind of the next wave of regulation in this world of water reuse?
Yeah, thanks for the question. One of the things that we're seeing throughout a lot of states is reuse of stormwater and rainwater in their processes. Some of the newer topics that we're seeing is use of gray water for facilities to reuse some of that water in a variety of different ways. So it's always slow on the regulation side, especially for waters. But if you check out the different websites and make sure that you're talking to your state regulators about what it is that they need, that's always the best place to start. But we are seeing a lot more movement on water reuse regulations, especially out west, like I said.
Great, thank you.
Yep.
Our next question here is for Aklima. Aklima, in your opinion, or based on your experience, what missteps do you think companies can make in selecting solutions for water reuse and water treatment?
I would rather answer it by saying what steps to avoid so you don't have those missteps in selecting the technology. How about that?
Sure.
Okay, so like I was saying, it's very important to make sure your treatment system, like the range of quality, the what is normal flow, what is maximum flow, all those things defined, right? Because depending on you might have some peak values that, the water is really bad, or you might have some peak flows that needs to be normalized. So your treatment system, for it to have the proper turndowns, the proper margins, and then again, you can't just design, if your normal flow is say 200 GPM and for 2 weeks in the year you have 500 GPM, obviously you cannot invest infrastructure for the max flow, right? So it's a little bit of balance. Maybe your plant would be okay for that 2 weeks to run all the redundant equipment at the same time, right? So it's a matter of dialogues with your client and definition of the project or design, developing the right design basis, I would say. The other thing is, equipment, after the performance guarantees has been done and you move on, it might not operate the same way 3 years down the line. So you need to give yourself a little bit buffer. I think those like basic, and there's many more, but again, it's all industry specific.
Right. Thank you, Aklima. Let's see, we got one more question here for Emily. Emily, what are the ESG goals out there for clients?
So certainly they'll vary by company, but I would say commonly we see goals related to overall consumption and goals around reduction of that water use, and specifically freshwater use. Certainly with the water stress pressures out there, as well as emerging regulation, metrics and goals related to recycling and reuse. And to some of the talks earlier, goals around shifting to lower quality water sources where it's possible to do that in industrial settings. I think on the most aggressive end, we have seen some companies, not a lot of them, but a few start to set goals that are beyond their walls and really providing a net positive impact related to water. And so I think from a stakeholder standpoint and a broader societal standpoint, some of those would be more on the progressive end.
Great, thank you. We get another question in the chat or from the form here. One of our members asked about scalability. So can reuse examples like this be scaled up to a municipality scale? You'll let Aklima start with that first, and we can go around the room if we have more to chime in.
Municipal, the kind of treatment system they have, it's typically very large flows. So within the confines of your facility, if you're thinking about what can be recovered and reused, again, I think it depends on your particular facility and whether like the treatment system and how much you reuse, the flows from the reuse, is it sufficient that it makes any impact? So it needs to be, I think a little bit more information is needed to evaluate that. But again, it's very project specific, but in my opinion, the flow rates are huge, and you have to see that, is it worth the $5 million to recover 2% of water or not? Or maybe that's your goal, and then it's okay.
Yeah, Sharon, anything to add for regulations on that side of things?
Yeah, I guess I kind of go back to my response regarding the regulations in gray water. I think you'd be seeing a lot more opportunity with some slipstreams being used for reuse, rather than looking at a whole municipality for that type of consideration. So we've seen some more of that than full city implemented. And I think, as Aklima said, it would be really difficult based on the volume that you've got to have a fully complete reuse system for municipalities.
Got it. Emily, anything to add?
I was just stepping back, thinking more about some of the industrials. And, you know, we went through this process today throughout the presentation that looked a little bit linear, and it really is an iterative thing. And as we've worked with companies, both those that are driven to act by regulatory requirements, but also those that are trying to differentiate from a brand standpoint and really lead with sustainability. The scalability considerations are really, really important as you continue to assess the water balance, look at what's happening outside of your walls, and then be thinking about how do you deal with all of this as your operation is growing. And I think folks try to plan for that, but they continue to grapple with it. So those assumptions and the quality of modeling that is done to plan for how much you need to treat, how that might change over time is really, really important.
I wasn't sure if the question was, and you know, whoever made that question can contact me if you want to discuss further, but if the question was scalability, like, okay, maybe you're a municipality, you want to, you know, further treat your gray water, make it drinkable water quality, and maybe now you have funds to treat 1 million gallon per day now, and you want to be able to scale that future for 2 million, 3 million to the maximum capacity of your facility and how much funding you have. So yes, that can be done if that's the question that was asked. You just have to plan for it ahead of time.
Great. Well, thank you so much to our speakers. Maybe I'll just give one last 10 seconds for people to submit questions in the form. But if not, then I think we can wrap up maybe 5 minutes early. Again, we do have the slides that will go out to all of the attendees, and we wanted to just thank you for joining us today. And if you have questions about regulations or setting your goals or, you know, having the right, you know, process for yourself, reach out to us and we can be free to answer any questions after the session today.